So if you remember back in week 2, there was a course assignment introduced, and this course assignment is due the last week of class. So as you scroll through the assignment, there's a lot of different things, but the big bulk of it is there's 6 major points you should be looking for. Your assignment should define an interface with the following definition, define an enumeration with the following definition, define a device class that performs the following, create a class that's called measuring length device that performs the following, build a user interface that meets the following requirements, and then for your submission, you're going to be submitting your code and capturing the some required screenshots showing your program running. Underneath, there are some tips that may be a little bit unclear. I've gone through and kind of taken basically everything that's in here in the course assignment, and if we come back and you go down to course projects tips, you'll now see that there's a course assignment help PowerPoint. If you click on that, it basically takes all the requirements that are in there. While we wait for it to load. Takes all the requirements that are in there, definition, the assignment, and remember this is approximately 50% of the grade. If you do not submit this assignment, you will not pass the class. So submit what you have done if you don't finish it. But this kind of just breaks it out a little bit easier to understand. Here's the first requirement. Here's the second requirement. Here's the third requirement, the fourth requirement. And notice that coincidentally that the fourth requirement kind of takes up 2 pages. If you look at the rubric associated with the course assignment, there are two different parts of the rubric that are associated because this is where a bulk of the work of your project is going to be going on. The 5th requirement for the user interface, and then the 6th requirement showing what the shots are. I also went through and basically in the bottom of the assignment is some sample code for doing things that I kind of broke them up a little bit more to go through. So if you notice, there's a code in there to create a fixed queue. This allows you to work with your data as you're putting your data into a list. It allows you to put it into a queue that is a first in, first off FIFO type of queue. So basically this will allow that every time you put something in there, if you have a queue limit of 10, when you put the 11th item on, it's going to go into the top of the list, and then it'll take the first item out automatically. You don't have to do any special code. This code here will provided will go through and do that as long as you use it. There's also sample code on how to use the timer. If you look in there, the biggest thing is that this timer runs off the system threading timer. Here's the code to define your timer. This timer starts after a second and then runs every 1 second further. So this is based off the definite requirement in the device. And then what it's doing is it's calling this method timer tick, which is defined here. Another thing that there's also a separate video about, but I also have a tip about comments, where if you look in the rubric and you look throughout the assignment, it talks about comments for developers using your class. Well, sometimes those comments are simply as hitting three slashes, and Visual Studio will automatically fill in a template similar to this with summary, a blank line, and summary. And if you type in what your class does, in this case, this is a property that returns a current value that's within data that comes from our device class. If I type this in here, when I make a call to my device, get measurement, as I mouse over get measurement, you notice this is the comment comes up. This is what a developer comment does. So now to switch over to Visual Studio, I'm going to click play. And my project is going to compile. So now you kind of come up and you see, as you're starting to see Visual Studio going through, this is my user interface. It's very simple. It's not complex. It has all the required elements within it. It has the ability to switch between inches and centimeters, which inches is imperial, centimeters is metric. I have a place to display the most recent value. I have a place to show the raw data history. I also have within here using system delegates and such like that, which I'm going to explain in a little bit. I have that when I click the Start Collecting Data button, notice now things are running. After 1 second, I've gotten the first data. Here's the raw data coming from my device. I'm making the assumption that my device always returns imperial units. So if you notice that my raw data is going to match the inches. So my raw data is 4 inches. Now I've come back and the next raw data item is 10 inches and it's showing it returned 10 inches. So now while my device is running, if I switch over to centimeters, when the next measurement comes through the system, which is every 15 seconds, you will now know that, see, the raw measurement was 2, but now my most recent measurement has been converted to centimeters, which is one of the requirements. So now, as you see, we should be coming up on the 4th item in there. And again, it returned it in centimeters. We'll switch back over to inches. And the 5th item should be popping in shortly. There's the 5th item. And the 6th item shall be coming over. And remember, in the requirements, our device is running in the background. Our device is generating a value every second. Our measuring length device is also running in the background, and that is collecting values every 15 seconds. So there is a difference in timing so that you don't sit there and see. And if I wanted to down here in my output window, I could have it have my device output to this window so I could see it running and see the numbers coming in every second. But that's the way everything is configured in it. So now we're up to 7. We should be seeing the 8th value shortly. Then after another 15 seconds, we should be seeing and the 9th value should be popping in shortly. So now we have 9 values. We should now have a 10th value pop in shortly. So there's our 10th value. So now if you'll notice, I want you to pay attention that the first value in my data history is 10. I've set up my queue to be a 10 item length. If you notice in the code samples, we have a tool that's called the fixed queue. That is a fixed length queue. So if you notice now, as my 11th item popped in, my first item popped out because we're only showing a data history of 10 items. So that's using that fixed length queue, and that's kind of why I've had the process running. And as you see now, as each value is getting added down here at the bottom, the topmost item is disappearing off the top of my queue, which is what the fixed length queue automatically does for us. When I click stop collecting, as we sit there, the program will sit there. And if you look over here on the right in the diagnostics, you'll see that my program is still running, waiting to get to a point to where a new value would have been popping in right about now. And notice there's no new values. We're stuck at the last value because we've stopped collecting data. We stopped collecting data. Now the device is still run. Now our device, our virtual device, is still running, and it's still generating numbers every second, which was a key in the assignment. But our data collector is not collecting anymore. So now that we've done that, I want to kind of go through and highlight something in the code that is an additional thing, that instead of having a button that you push to get your raw data and a button to get the most recent measure, you notice how my program started going through where it was essentially streaming the values from the device to the screen. And that's done through a special class that I have here that's called the main data display. So up here in the main data display, I have I'm using the two main things that I'm using that are built into it. I'm using system.component model and system.runtime.compiler services. This allows me to that now when I sit there, I can have my main data display class inherit and implement this interface that's called iNotifyPropertyChange. And what this allows us to do is this allows us to create a public event that is called the property event that's of type property event change handler called property change. Delegate that event, and I'll show you more how to do it down below, to where basically as a specific property is changing, this will allow our user interface to get notified that the property's changed and update the screen. So if you notice, I have a I have a property for history and a property for measurement, and the getter for just returns the current value of history, and the setter sets the new value for history, and then triggers the on property changed event, which we'll get into the code before. If you notice, I have a string for the measurement, most recent measurement, and a string for the history. And again, here in the measurement, I return the current measurement, or I set the measurement, and then when I set the measurement, I trigger that the property has changed. And notice that all that happens if measurement, if the value that I'm in the setter is not equal to the measurement. So only if the measurement's changed is this code happening. And the same thing with only if the history value has changed is this code happening. And then the last part of this code here is the on property changed event definition. So with this public void on property changed call member name string property name equals null. Basically what this is saying is it's going through, and as you notice in our two properties, we're making a call to the on property change method. And since they're coming from a property, it's passing in the property name and it's triggering this property changed event with the property changed event arg of the name. So how is that used? Well, if I come over into the code behind for my class, you notice in my class, I've got definitions set up to go through and trigger all my events and stuff like that. But one of the things I have in here is in my, I'm running a third timer that runs in sync with the measuring length device timer. So that way I can go through, and when I click start collecting, I can have create my own timer that goes through and runs in sync with my measuring length device, collecting the values. And then when that timer has an event click, I go through and I check to see whether I'm looking for imperial or metric values. I go to my measuring length device and get the current metric value, or current imperial value, or current metric value. And notice I set it to I don't set it to my field. I set it to the display data I set display data measurement to the field, and again display data measurement, and then I'll get the measuring length device history. So basically, display data is defined up here as type main display data, which is the class we created. On the initialization of the form, we set display data to our new main display data, and we initialize the history just to set everything up. And then we also do another thing where we set the data context, which is what we're going to use to tie the display data values to the form. We set the data context for the form to the display, to the value of the display data object. So now the last thing that I'm going to go through and show you is I'm going to go to our main page, the XAML for the main page. So if you notice in here, I have two text blocks. I have a text box for the most recent measure text and a text box for the raw measure text. So as I scroll over, one of the things that I have set up on here is, if we look, you see we have in here in the text property, I have a special binding going on. Oops. That because I've got that display data and everything set up, I've got, stop scrolling. I've got it set up to where I do this special X bind, and I just bind this text, the most recent measure text to the display data measure. I set it up as to it's only one way, so therefore it's only receiving the data. It's not going to be sending data back through this binding. And then I have a fallback value of most recent measure. And the same thing for here. I have where I'm displaying the raw data to the history, display data.history. It's a one-way binding again, and the fallback value is the raw data. This class setup combined with this code these lines of code, and then setting the display data history and measurement in my timer is what binds the values coming from my device class over here through my measuring length device, and then finally binds it to where it automatically displays on the form. So therefore, I'm not required to have buttons to push. So again, if I go through and I actually am going to go through and make sure that I have a reference to the debugger. And I'm not sure. Debug.write line. So now in my time, and the reason I did this just so that this way, when we run our program, I want to point something out as the program is going through and starting. And output window. So if you sit there and you look, notice in my output window, in my program, I have not started collecting. However, when my program starts up, my virtual device starts going through and it starts generating measurements every second. So as you see, it's showing the current device measurement. So when I click on start collecting, you're now seeing the 9, because my data collector is only going every 15 minutes. However, just because my data collector is measuring every 15 minutes does not mean that my device is set to run where my device is generating measurements every 15. The data collector collects the data every 15 seconds. The device sends out measurements every second. So in other words, to kind of summarize everything that this is going on, we're writing a program that someone would use to connect to a machine that is going through and taking measurements of something. This machine we're creating a virtual device to replicate this machine, and this machine generates measurements every second. However, the requirement for our data collector program for the user to kind of just track what's going on with this virtual device, the requirements are that this part only collects measurements every 15 seconds and shows them to the user and gives the user the ability to switch between imperial measurement and metric measurement. And one of the things, as you notice, my device is always just returning integers. However, when I come back into my raw data history and so the raw data is essentially only integers, but as I go through and I switch between imperial and metric, it's converting the raw data, which is assumed to be imperial, and converting that imperial measurement into a metric measurement. And that's the whole purpose of this project. If you guys need any help, there are 3 more opportunities, and if you need more, I can set up more, but I actually have time set aside for virtual office hours where I can go through and we can either do a one-on-one Zoom session or do a multi-person one Zoom session. We can work on it either Monday evening, this coming Monday evening, this coming Thursday evening, or the following Monday, because after that, we're pretty much at the point where everything is due. So if you have any questions or you have any further comments regarding the project, let me know. I will be going through reviewing what you submitted for submission, and I hope this has helped some. Thanks.